This video is over topic 21, normal distribution characteristics. So make sure you read and understand these characteristics of normal distribution. Mean, median, and mode are equal. The distribution is symmetric about the mean, and it has a bell-shaped curve. So some examples of what that can look like, or the nice smooth version of it. But the actual practice question here is looking at the idea of using area, particularly the area under a histogram curve, to describe probability. So here's an example. This isn't normal distribution, but it's just a type of distribution defined by this shape. And so we have these different regions. We're told the area of each region. And so this, like, we could say the height of the curve at any given point is the frequency of that value. But this is also looking at, we're not just choosing whole numbers, we're choosing any real number. So I could choose this number here, or this, anywhere in there. So I'm not just limited to choosing whole numbers. So the probability of choosing a number is based on not just the height at that particular number. So basically, we would look at the probability of choosing any specific number as 0. We could only really talk about the probability of choosing between two numbers, or less than a number, more than a number, so that we actually get area. So that single line doesn't have area. But like the area, or the probability of choosing a number between 5 and 8, that would be anywhere in here. And that would be the region between the vertical lines at 5 and 8. That's region C, so it would be probability of 0.4, or 40%. So probability of choosing a number greater than 3 would be, and I'm actually going to, just for sake of being able to see the graph while I'm looking at the questions down below, I'm going to get this in a separate little window here. And bring this over here and this here. All right, so the probability of choosing a number greater than 3. So here's 3. Greater than 3 is everything over here. So that would be all the areas to the right of 3. I didn't grab the so A is 0.2, 0.3, 0.4, and 0.1. These all add up to 1. They're representing percentages of the whole area, or the whole area is 1. Zeros don't really need to be there, but they were there on the chart. So greater than 3. So that would be regions B, C, and D. So add those up. And that is 0.8. Or we could look at this as choosing a number greater than 3 equals not less than 3. Or in other words, I'm saying everything but this. So all except A, mathematically would be all would be 1, except A would be minus the area for A. 1 minus 0.2 also gets 0.8. So a little shortcut there. Then what's the probability of choosing a number between 3 and 8? Use a different color here. So between 3 and 8, here's my 3, here's my 8. Between 3 and 8 would be these two regions, B and C. So 0.3 plus 0.4 is 0.7. And then what's the probability of choosing a number between 5 and 10? So that's 5 and 10. In between those is region C and D. So 0.4 plus 0.1 is 0.5. So then the final characteristic of normal distribution is that the standard deviation, if the standard deviation is used as a scale, then if that's used to divide up the normal distribution curve, so we have the mean in the center, and if we go one standard deviation, I said it's the majority. There's actually, when it's normal distribution, there is a specific percentage that are, there's a specific part of the area when you count by standard deviations. This is a fixed area for any normal distribution when I do one standard deviation. So that means all that has to happen is somebody calculated those. Just like we had these areas given to us, somebody has calculated these areas. If I go another standard deviation, this has a fixed area. Somebody has calculated all of those for us. We just have to have a place to look them up. And this we'll do and see in later sections. But this is just looking at seeing area as a probability.